Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, I have designed 7-pole lumped element low pass filter using 4 open circuited stubs. In this design, I used high impedance transmission line that have a characteristic impedance of 110 ohms. In this high impedance transmission line, I am using line width is 0.1 mm. In this video, I am going to design same design 7-pole lumped impedance 7-pole lumped impedance low pass filter using 4 open circuited stubs. So now here in this design I am using the characteristic impedance of the transmission line is 93 ohms. So this characteristic impedance of 93 ohms line width is 0.2 mm. So this is the structure of the figure of the 7-pole lumped element low pass filter. There are 7 elements. So 3 capacitive elements and 3 inductive elements. And these 4 are the open circuited stubs. And these are the L2, L4, L6 are the inductive elements. That is the second design 2. So, and operating frequency is 1 GHz and material is Roses RT or Duraid 6010 and its dielectric constant is relative permittivity is 10.2 and thickness of the substrate is 1.27 mm and WC is 5 mm and characteristic impedance of the transmission line 93 ohms and its transmission line width is 0.2 mm. So that is design 2. So now here in this design the width of the transmission line 0.2 mm, the length is 5.39, the inductive element L1 and L7 is 5.39 and L2, L6 is 16.39 and L3, L5 is 8.67 mm and L4 is 18.93 mm and the open circuited stub width is 5 mm. And adding all these values, so both the ends I am using 10 ohm transmission line and then 50 ohm transmission line. The 50 ohm transmission length is 10 mm, 10 plus 10, 20. So now here I am using 4 open circuited stub and each stub length is width is 5 mm, 4 into 5, 20. Plus, and after that using inductor L2. So the inductor L2 length is 16.36 plus L6 16.36 plus inductor L4. So inductor L4 is 18.93. So the total, adding all the elements of this structure, so the length of the transmission line is 91.65. So I am considering the length of the substrate is 91.65 mm and the width of the substrate is 70 mm. So now open HFSS software. So this is the layout structure of the previous design 1, that is 7-pole lumped element low pass filter using open circuited stub. In that design I am using 110 ohm high impedance transmission line and width is 0.1. So now here design 2 I am using 93 ohm characteristic impedance. That 93 ohm characteristic impedance line width is 0.2 mm. So I will modify this design. And length of the substrate is here 91.65 mm and width of the substrate is I am considering 70 mm and thickness of the substrate is 1.27 mm minus 1.27 And position, x position value is half of the x size value before representing negative sign, minus 91.65 by 2, and y position is half of the y size value before representing negative sign, minus 70 by 2. Press OK button and change the dimensions of the ground plane. The dimensions of the ground plane is same as that of the dimensions of the substrate, and x size is axis is the z axis, x size is 91.65 and y size is 70 mm, and position and x position is minus 45.825 and y position is 35 mm and z position is minus 1.27 mm. So this yellow color is the substrate and this red color is ground plane. So on the top of the substrate we can design lumped element low pass filter. And first change the dimensions of the 50 ohm transmission lines of the both the ends. So this is 50 ohm transmission line, and the 50 ohm transmission line, the width of the 50 ohm transmission line is 1.1 mm and length of the 50 ohm transmission line is 10 mm. Axis is the z axis and x position is 45.825 and half of the length of the substrate 91.65 by 2 is 45.825, and y position is half of the y size value before representing negative sign, minus 1.1 by 2, and z position is 0. So press OK button and change the dimensions of the another end of the 50 ohm transmission line, and this is another end of the 50 ohm transmission line. So now here x position is minus 45.825. Next element is 4 open circuited stub. First open circuited stub element is capacitor C1. So change the dimensions of the capacitor C1, and the capacitor C1 x size is 5 mm and y size. So now the capacitor that y size is L1 5.39 mm minus 5.39 mm, and position and 50 ohm transmission line x position is 50 ohm transmission line x position is 45.825 and length of the 50 ohm transmission line is 10 mm. Subtracting that length of the 50 ohm transmission line from position of the 50 ohm x position of 50 ohm transmission line. So now we are the this open circuit stub x position is minus 35.825 minus 35 point sorry plus 35.825, and another end of the capacitive element. So change the dimensions of the this capacitive element C7, So this end of the stub exposition is 35.825. So minus 35.825 minus 35.825 plus minus x size. So minus into minus plus 5. So now here the exposition value is minus 30.825. Minus 30.825. Press OK button. Next element is inductor L2 and L6. So change the dimensions of the inductor L2. This is inductor L2. Inductor L2. So inductor L2, the exposition is 30.825. 30.825 and y portion is 0.55, z portion is 0 axis is the z axis, and this inductor L2, that length is 16.36. So minus 16.36. And now in the second design, the width of that inductor is 0.2 mm. So minus 0.2, press OK button and change the dimensions of the another end of the inductor L6. So this is L6. So now here the exposition is, and this inductor element exposition is, so minus 30.825. So minus of this exercise value. So minus into minus plus 13.32. So now the exposition value is not this exposition. This is 16.36. This exercise is 16.36. So minus the 30.825 plus 16.36. So which is equal minus 14.465. So this exposition value is minus 14.465 and y portion is 0.55 plus, and this y size is width is 0.2. Press OK button. So this is another end of the transmission line. And after that, change the dimensions of the capacitor element C3 and C5 and the capacitor element C5. So the capacitor element C5, that width is 5 mm and length is C5. .67 L3 8.67. So change the dimensions of the capacitor C5. Now the exposition is minus 14.465 and y position is 0.55. Axis is the z axis. C1 C3, sorry, now first C3, first change the C3. So C3 is, this is 14.465 and y position is 0.55, z position is 0, axis is the z axis, and exercise. So now the exercise is that width of the open circuit stub is 5 mm minus 5 and y size is 8.67 mm. So minus 8.67 mm. So now press the OK button and change the dimensions of the other end, that is capacitor C5. So now here minus 14.46 minus 14.465 plus 5 minus 9.465. So this expression is minus 9.465 and y position is 0.55, z position is 0, axis is the z axis, and x size is minus 5 and y size minus 8.67 mm. Press OK button. That is another end. So next change the dimensions of the inductor L4. So now the expression is 9.465, y position is 0.5 mm and x size. So inductor L4, that length is 18.93 mm minus 18.93 mm and width of the line is 0.2 minus 0.2. Press OK button. So this is the layout structure of the minus 18.93. This width is minus 0.2 and position is 9.465 and this is the layout structure of the 7-pole lumped element low pass filter high impedance transmission line. That characteristic impedance of the transmission line is 93 ohms, so whose line width is 0.2 mm. So these are the modifications of the second design. So 93 ohm characteristic impedance modifications, and after that change the dimensions of the port 1 and port 2, and the port 1 and this exposition is port 1 is 45.825 and y position is minus 0.55 and width is 1.1, z size is minus 1.27 and another input port to change the dimensions of the port 2. So this is minus 45.825 Now check the validation, design validation. So design is successfully validated. Now start the simulation. Press analyze all button. So simulation is successfully completed, and after that observe the return loss plot and insertion loss plot. So this red color curve is the return loss plot, and this green color curve is the insertion loss or transmission plot. So this is second design. Second design means 7-pole lumped impedance low pass filter using 4 open circuited stubs. So in this design I am using the characteristic impedance of the transmission line is 93 ohms and the line width is 0.2 mm. In my next video I will compare these two designs, design 1 and design 2. So design 1 is characteristic impedance of the transmission line is 110 ohms with line width 0.1 mm, and the characteristic impedance of 93 ohms transmission line and its width is 0.2 mm. So comparing these two designs in my next